Hi everyone, so welcome back to my channel Mathematical Swati 3226. In today's video, we are going to talk about 3D shapes. We are going to basically focus on four things about 3D shapes: how to find out the perimeter, how to find out the total surface area, how to find out the lateral surface area, and how to find out the volume. Now, there is a confusion I have seen among a lot of students that they always get confused between total surface area and lateral surface area. So everything is going to get clear in this particular video. And I'm talking about four things: perimeter, total surface area, lateral surface area, and volume of only two shapes, cube and cuboid. So once you understand cube and cuboid, then we can go to the other 3D shapes as well. Otherwise, this video will become very long. So that is why I'm just going to cover the two shapes, cube and cuboid. So let's start. I'll share the screen and we are going to start with first cube. Because cube is, or maybe we can start with the cuboid because cube is going to be very simple. So once we understand the difficult one, even cuboid is not difficult. But as compared to cube, it is, one can solve that first, right? So let's start with the cuboid and then we are going to go with the cube. So first of all, let me draw the cuboid. If you are aware of how to draw the cuboid, very good. But if you're not, this is the simplest way to draw the cuboid, that you draw a rectangle and then you take another rectangle and you start it from the center, like not the center, but from the inside. And then you do it like this. Yeah. And then you just need to join the vertices. Okay. I'm just using some words, vertices, and the other words I'm going to use, but I'll be explaining all the words. Okay. So this is how we can draw the cuboid in a very simple way. So if you notice, a cuboid is actually made up of rectangles. You can see a lot of rectangles, right? So let's get started with this one, with the cuboid. So first of all, let us understand the basic things, that there are 8 vertices in a cuboid, right? 8 vertices. These are called vertices, 8 corners, right? So we have how many vertices? We have 8 vertices. Now you can also see here that we are having the boundaries, right? That is called in 3D shapes, that is called as edges, right? So I'm just going to use the vanishing pen so that you can see that I'm talking about this, 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 and this. So we have 4 boundaries on the top, 4 boundaries in the bottom, 8 boundaries, and 4 the standing line. So how many total boundaries we have? 12, right? But that we don't call as boundaries for the 3D shapes, or we don't call it as sides, we call it as edges, right? So I'm just writing here edges. So how many edges do we have in a cuboid? 12, right? Edges is the boundary again. Now we have how many rectangles here that we call as the faces, right? Faces, that means for which, like from which 2D shape it is actually made up of. It is made up of rectangle, right? So those rectangles that you can see in the boundary only, that are called faces, right? How many rectangles are there? Again, if I use the vanishing pen to explain you this part, you can see that there is a rectangle in the front, right? One face. There is a rectangle in the back. Let's talk about the opposites. Front, back, 2 faces. On the top, 3 face. Bottom, 4 face. Left side, 5 face, and the right side, 6 face. I have covered all of it. So therefore, how many faces do we have? We have 6 faces. So that was a very basic thing. We have how many vertices? 8. How many edges? 12. How many faces? 6. From which 2D shape a cuboid is made up of? A cuboid is made up of a rectangle 2D shape. Overall, of course, it is a 3D shape because it has 3 dimension, length, breadth, and height. I have talked about these basic things like, what are dimension and everything in my previous video only. So if you open my channel before this video, that video is there, right? So you can watch that video too. Now let's talk about the dimension, which is, I'm saying length, breadth, and height. So here we have this as the length. And this is nothing but the breadth. And then the standing line that you can see, that is the height, right? Now, as you know that this is made up of a rectangle, and we know one property of a rectangle, that in a rectangle, the opposite sides are same. That means if this is L, this is also going to be L. When I'm saying this is also going to be L, I'm talking about this part, right? This is L, this is L. This is also L, and this is also L. right? So they are all going to be L, 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 right? So this is also L, this is also L. Similarly, if this is B, this is also B. The edge I'm talking about, we have 12 edges, right? Out of that, 4 edges are L, length. 4 edges are breadth, B, B, and B. And 4 standing lines are the heights. I think I should be using different colors. So for B, I'm using the red one. For L, I have used the blue color. And for height, I'll be using a different color. So that will differentiate also. I can use the color green. So we have first height here, second height, I think I'll be erasing this. The second height here, the third height here, and the fourth height here, right? First, let's talk about how to find out the perimeter of a cuboid, right? As you know, again, I have explained this already. Perimeter means the sum of the length of the boundary, right? So here we need to find out the perimeter of the cuboid. Okay, so please write down the formulas also. So perimeter of a cuboid is going to be the sum of all the boundaries. Here boundaries means all the edges, right? How many edges do we have? 4L, L plus L plus L plus L. How many breadths do we have? 4 breadths. B plus B plus B plus B. How many heights do we have? 4 heights. H plus H plus H plus H, right? So if you just add all of them, I'm just going to change the color so that it will look more vibrant. So L plus L plus L, that is going to be 4 into L, right? So that I can also write down as 4L because there is a hidden multiplication sign, as you know. B plus B plus B plus B is 4 into B plus H plus H plus H plus is 4H, right? Now, of course, I can take here 4 common, right? 4 I can take common because it is coming in all the expression. So that is why I can take that 4 common and I can write down 4 times L plus B plus H. And that's our perimeter of a cuboid. That's the formula, perimeter of cuboid, and that is our first formula, right? I'm not going to solve any question here because the reason is the video will be unnecessarily longer. I'm going to just cover all the formulas and my next video is going to be on questions. So the next video will be completely based on our practice. We can do a lot of questions where we can use all these formulas that I'm talking about. So let's keep this video just for the formulas, right? So here I'm not giving you directly that, okay, perimeter of a cuboid, 4 times L plus B plus H. I'm also explaining you how exactly it is 4 times L plus B plus H, right? So this is our first one, perimeter of a cuboid. I hope this is clear. We can go to the next thing, which is going to be, of course, our total surface area and lateral surface area. Let us cover that first. I'm just going to do something special here. I'm going to take a picture of this shape that I have drawn so that I don't have to draw it every time. So I'll take a picture of my cuboid and I'll be using the same cuboid for everything. All right. So the picture is done. Now I'll be, oh, all right. Okay. So these are my previous things. I did not realize that. Anyway. Yeah. So this is the rectangle, right? I mean cuboid. Okay, so we have talked about perimeter already. Now we can go to the total surface area. Let us understand what is the meaning of total surface area first. That I'm going to make you understand with the help of a book that I have, which is looking, of course, which is cuboid in shape, right? So what is the meaning of perimeter as you have already understood, but still I'll make you understand with the help of this book here. That perimeter is the sum of all the edges, right? So how many edges do we have? See, you remember B and B, 2B, B and B, 4B, so 4 breadths and 4 lengths, 2L, and here also 2L, 4 lengths, and we have 4 heights, 1, 2, 3, and 4, right? So we have 4 heights. So that's how we got the 4 times L plus B plus H. Now let's talk about the surface area. First of all, I'll make you understand what is the meaning of surface area. Surface area, that means we're talking about the part that you can see here, this part, this part, this part, this part. There is something inside also, right? We're not talking about the inside part, surface. On the top, bottom, left, right, back, front, right? I'm talking about that. So here, all these spaces I'm talking about, that means, and all these spaces are what? All these spaces are rectangular, right? 1 second. Yeah. So all these faces are, of course, rectangle, right? So I'm just going to find out the area of all the faces. The top face, area of top face, which is rectangle, area of the bottom face, which is also rectangle, area of the back face, which is also rectangle, area of the front face, which is also rectangle, area of the left face. For you, it's left, and for me, this is left. And area of the right face, right? So if I just add all of this, it will become the total surface area of a cuboid. That's it. Now, if I talk about lateral surface area, what's the difference between total surface area and lateral surface area? Sometimes we also call lateral surface area as the curved surface area. So lateral or curved surface area means that we are talking about only the side part, okay? Removing the top and the bottom. So you cancel the top part and you cancel the bottom part. The sideways are called actually the lateral. That's the English word also, lateral side. Or we also call it as a curved side, okay? So that is the meaning of lateral surface area. I'm going to use any one word so that you don't get confused. Remember, either you can use curved surface area or you can use lateral surface area. In some books, you can see the word lateral surface area. In some books, you can see the word curved surface area, okay? So that's the difference. Let's go and let's find out the total surface area of a cuboid. So here, the total surface area, I think I should be using TSA only, right? Because that will save my time. Next time I'll write down TSA and LSA. So here total surface area of a cuboid is going to be the sum of area of the front part plus, I'm not writing the word now area of the back part plus area of the top part plus area of the bottom part plus area of the left part and plus area of the right part, right? Now, what is the area of the front part? If I just again use the vanishing pen here, I'm talking about this rectangle. So what is the area of this rectangle? Area of a rectangle formula is length into breadth. But here the length is L, but the breadth word we have, like, of course, the letter you can see H. So that's why it is going to be L into, L into H. That's the area of the front. Front is done. Now, similarly, if you look at the back one, if I just annotate for that as well, I'm talking about this back rectangle. That is also length into breadth. So length into breadth is H. The letter is H that we are using. So that is also going to be L into H. So that is our area of the front. Now let's go to the area of the back. I'm sorry, area of the front and area of the back, right? Now let's go to the area of the top. So if you look at the top one, that's also a rectangle, but there it is L into B. So that is going to be L into B. Plus, similarly, we have area of the bottom, also same thing, L into B. Plus, we have area of the left also. Let's change the color. So area of the left is going to be, if you notice here, if I again use the vanishing pen here, I'm talking about this rectangle. So B into H, that will give us the area of that face. So that is going to be B into H, the left part, plus area of the right part. That is also B into H, right? Now, in the simple word, we can just write down L into H as LH. Again, L into H is LH. L into B we can write down as LB, plus L into B again we can write down as LB. And B into H we can write down as BH plus BH. Now you can see that LH and LH is getting added 2 times. So I can write down this as 2LH. I can write down LB plus LB as 2LB. I can write down BH plus BH as 2BH, right? So as you know that if I'm having, let's say 2 plus 3 plus 4, and if I'm writing that as 3 plus 2 plus 4 or 3 plus 4 plus 2, that's the same thing. I'm going to do something like that, right? Why? So that you can remember the formula. So I'm just making it more arranged. So twice of LB plus twice of BH plus twice of LH. That is how I'm writing. So that is why what is the total surface area of a cuboid? That will become, if I take the 2 common, why will I take 2 common? As you can see, 2 is coming everywhere, right? So that is why I can take that 2 common, right? Now if I change the color a little bit, because I have been using the same color. So twice of, right, LB plus BH plus HL. I know that you may find this very complicated, but how can I remember this? A very simple way. Just remember the total surface area of cuboid will be 2 times. That you have to remember 2 times. And then you write down somewhere L, B, and H, the 3 dimension. That's very famous, right? So just write on the combination L into B, L into B. B into H, B into H into L, and then add all of them, and that's the formula. That's a simple way to remember. That's how I had remembered when I was in school, and I still remember the same way. So yeah, that's the formula that of the total surface area of a cuboid. 2 times L into B plus B into H plus H into L. Oh, I think I did a blunder. Anyway, I hope you can just go back and you can write down the same thing, because I'm not sure how to do exactly the undo here. Okay, everything just got mixed up. Anyway, I'll do one thing. I'll just erase everything and I can just write down the remaining things as it is. 1 second. Yeah. So the total surface area of a cuboid will be, I'm directly writing here, 2 times L into B plus B into H plus H into L. And that's our formula for the total surface area of cuboid. Yeah. Just making it look more nice. So that's the total surface area of a cuboid. Now we can go to the lateral surface area, right? I'll be using the same diagram that I had taken the screenshot earlier. Yeah. Now we are talking about here the curved surface area. Curved surface area, as I had said earlier also, that we are going to remove the top and the bottom part. So if you just remove this and if you add the remaining ones, that will give you the lateral surface area, right? So I'm using the word LSA, lateral surface area of a cuboid. So what is that going to be? Let's start. Let's add the front one first. Area of the front face. Area of the front face is going to be L into H. Similarly, we have area of the back face also, which is also going to be L into H, plus area of the left face, which is going to be B into H. So I'm directly writing BH plus area of the right face, that is also BH. Now what is LH plus LH? That is going to be 2LH. And what is BH plus BH? That is going to be 2BH, right? Here I'm going to take not just 2 common, but I'm going to take something else also common. 2 is same, as well as H is also coming common, right? So I'm going to take the 2H common. So if I take the 2H common, then what is left? It's L plus B. So that's why what is the lateral surface area of a cuboid? The formula is 2 times H times L plus B. That's the formula. Next is the volume, right? So I'll explain you how to find out the volume. For that, I will be just taking the same shape again. First of all, let us understand what is the meaning of volume, right? Volume means there is a difference between area and volume. Area, we talk about 2D shapes, right? And area, we also talk for 3D shapes like I just did. But when you have a rectangle, you find the area of a rectangle, right? Because it's a 2D shape, we can find out this the space inside that rectangle by using the word area. But in a cuboid, it's not called area. It is occupied some space, but that space is called as volume. So I'm talking about this space that you can see inside, right? You can arrange some balls here, right? You can arrange all the balls. You can arrange the stuff. So that space I'm talking about right now, and that is what we call as a volume, right? So this is what we call as the volume. What is volume? Volume is nothing but the space occupied inside the shape. Space occupied inside the shape. All right, so this is what this is what volume means, right? Now let us find out what is the volume of a cuboid, right? If you notice one thing here, like here you need to understand one thing. Let's suppose I'm drawing a rectangle here, okay? And then I'm drawing another rectangle. Or let's say that you're taking a sheet, rectangular sheet, and then you're taking another sheet, another sheet, another sheet, another sheet, another sheet. And you're just taking making a stack of sheets. So will you not get a cuboid? You will get a cuboid, right? Same way, using that concept, we can actually find out the volume of a cuboid here, right? So if I just talk about the same book once again, right? If I'm taking just the first page only, right? This one. Forget about this whole book. Just this one. So this is a rectangle. Now I'm just keeping another rectangle on this. another rectangle on this, another rectangle on this. So it's like I'm arranging stacks of rectangles on top of each other. And that is what we call as a cuboid, right? Now imagine that I'm talking about only one sheet that was rectangle. So what is the area of a rectangle? Area of a rectangle, we know length into breadth. But such L into B, we are arranging for how many times? You can see a height that we are getting. So it's like one, okay, if I use the vanishing pen, one rectangle, another rectangle on top of it, another rectangle, another rectangle, another rectangle. How many such rectangles? H such rectangles, right? So what are you going to do? You're just going to multiply the H here. And when you do that, what are you getting? You're getting a box, right? And that is what we call as the volume. So that's a very simple way to understand the volume of a cube. So that is why directly I'm now saying the explanation I gave you. The volume of a cuboid is nothing but it's L into B into H. That's the formula. So that's what we call as the volume. So if I just summarize all the formulas, all right, I can see something that it's not going. Yeah, that's perfect. That's working. So if I just summarize all the formulas that I talked about just now for the cuboid, I'll just write down here and you can also write down in your note, right? So first was the perimeter of the cuboid, right? So what is the perimeter of the cuboid? It was 4 times L plus B plus H, where L, B and H, as you know, length, breadth and height. The second formula was the total surface area of a cuboid. I'm using the short form TSA. TSA means all the spaces that we find out the area of all the faces. The formula was, if you remember, it was 2 times L into B plus B into H plus H into L. Now let's talk about the curved surface area. I'm using a different color. Yeah. Okay. Yeah. So lateral surface area, or we also call it as a curved surface area, LSA or CSA, whatever you want to use. The formula will be 2 times H, if you remember, and then L plus B inside the bracket. And now we have the last one, of course, and that is called the volume of a cuboid, and that is called L into B into H. Trust me, if you know these formulas, the basic questions you can easily do, right? Because it is completely based on the formulas, right? So I'll just draw this. It's in a 2D shape, rectangle. But yeah, that is cuboid. Now I think we can go to the next one, which is cuboid. And now it is going to be very simple. Why is it going to be very simple? Because now we have understood the, cuboid in very much detail. So now this is going to be very, very simple. Let's see how. First, I'm going to, of course, make a cube. Cube is made up of a now square, right? Of course. Cuboid was made up of a rectangle. Cube is made up of a square. And this is what we call as a cube. What am I going to do here? I'm going to again add all the vertices. Now I can use the word vertices. Okay, I'm just drawing it with my free hand. All right, here you have to notice one thing, that vertices are exactly the same, the 8 vertices, just the way we had in the cuboid. Similarly, we have also the edges same, 12 only. Same way, we have also the faces same, 6 only, right? So that is going to be the same thing. So you may ask that vertices is also same, edges is also same. Then what's the difference? Of course, the difference is in the shape, right? That cuboid is made up of a 2D shape rectangle, and cube is made up of a 2D shape square, right? Okay. Cube is a 3D shape, but it is made up of a 2D shape. Okay. So edges, and now it is going to be, of course, 12. And faces, how many faces? Same way. Front, back, top, bottom, left, right. So 6, right? Now let's talk about the perimeter, right? Now there is one thing that we know. It is made up of a square, and square has one property. We all know that all the sides are equal, right? So if I'm taking one side to be A, this is also A, this is also A, this is also A, right? So here, this cube is also made up of the same square throughout, right? So this is A, this is A. There is no LBH problem, right? That is why it is simpler. A, this is also A, this edge is also A. What is the meaning of A? Length. Length, okay? It can be 2 centimeter, 3 centimeter, whatever, right? A. And A here also, right? You can basically pause the video also and you can try to understand all the figure. I'm going a little fast, but yeah. So perimeter is nothing but sum of the length of all the edges. So how many edges do we have? As you can see, A plus, how many edges do we have? 12. So it's very simple. A plus A plus A, how many times? 12 times, right? So that is going to be directly 12 into A. What is A? Nothing but the side of the cube. And that's the formula. 12 into side is nothing but the perimeter of cube. And that's our first formula. Now we can go to, I think I'll be doing the same thing. I'll take a screenshot of this cube so that I don't have to draw it every time. All right, perfect. So now let's go to the total surface area quickly. So for total surface area, again, I have taken the same cube. Oh, okay. Yeah. So for the total surface, just trying to go a little bit up. Yeah. So for the total surface area, TSA, it is going to be the sum of all the faces, right? So what is the area of the front face? Now you should know what is area of a square. What is area of a square? Side into side. So here that side is A. So what is area of the front face? A into A. That means A square. Plus area of the back face, A square. Now I'm going a little bit fast because as you know, for cuboid, we understood everything in detail. Plus area of the top face, A square. Plus, because all are square, right? Plus area of the bottom face, A square. Plus area of the left face, A square. Plus area of the right face, A square. So what's the answer? 6A square, right? Which we also call as 6 into side square. That is our total surface area. Total surface area of cube. Yeah, yeah, okay. That's our total surface area of a cube. Now, if I talk about the lateral surface area, right? As you know, lateral surface area, we need to remove two things, right? We need to remove the top and the bottom. And then remaining one you need to add. So what is the area of the front face? Area of the front face is A square plus area of the back face, A square. Top and bottom we have removed already. So area of the left face, A square, area of the right face, A square. So basically from 6A square, if you remove the 2, then what is going to happen? 4A square, right? So what is the lateral surface area of a cuboid? It is going to be 4 into side square. That's the formula. That is our lateral surface area. Now, same way, if I talk about the volume, right? If you remember volume, we had done already. That volume of a cuboid was length into breadth into height, right? Similarly, we have here, just substitute the L, B, and H with the side. So that is going to be A into A, which is also written as a cube. So that's why, what is the volume of a cube? The volume of a cube is nothing but side cube. And that's the answer. Now here, maybe some of the things I missed, like what is the unit and all the other things. All the other things I'm going to cover in another video, which is going to be only the questions based on volume, perimeter, total surface area, lateral surface area of a cube and cuboid, right? So I hope you understood all these formulas properly. I'll just write down for all the cubes together, just the way I had written all the formulas for cuboid together. Yeah. So I'll be writing the word cube. Oh, okay. Just a moment. Sometimes it happens. So I'll be, oh, sometimes I think most of the times. Anyway, that's okay. I think even if I write down the cube here only, and I can continue, right? So the cube, yeah, perfect. Everything should look neat and clean. So for the cube, we had first understood the perimeter. What was the perimeter of a cube formula? It was 12 into sine. Next, we had understood the total surface area of a cube. What was that? That was nothing but 6 into A square. I'm just going to use the word side. Side is A is side, same thing. So 6 into side square, right? And then we have the lateral surface area or the curved surface area, which was of course 4 into side square. And then we had the volume, right? So what is the volume of the cube? That is going to be side into side into side. That is going to be side cube. Okay. So this is for the cube. If I just put this into a, yeah, put it into a box. Yeah, that's it. So this is about cube and cuboid. These formulas, I hope these formulas are very clear now. Now the question is that why did I choose this video? So I'll just let you know that this is the topic that one of my subscribers randomly like I was just going through the comment section, and then I saw that one of the subscribers had written that tomorrow is my exam. Can you please explain me the concept of total surface area and lateral surface area of 3D shapes? So this is for you if you are watching this video. I don't know the name now. I've totally forgotten the name, but I hope this video was useful not just for you, but for all the other uh, subscribers as well. Thank you so much, and I'll be coming. I'll be meeting you once again in my next video with the practice questions. Yeah. All right. Thank you so much. Good night, everyone. Bye.